Hi, this is Rubaat Khan, and I'm here with a new video where I'll be solving a new problem. The problem states that we are given a list of elements and we have to count the number of occurrences of each item in the list. So over here we're given a list L. This is just an example. We're given a list L which contains some elements like fruits, and if you look at the expected output, each fruit is printed or counted and prints the number of times it's found inside the list L. So before starting, you have to make sure that, or we have to be very careful about one thing, that we do not work with the same element, or we don't work with one element twice. Okay, so let's get started. So how to think of the solution. So let's say this is a list we have, or we have these items. So let's use our logic to solve the problem. What we can do is every time we can select an item and then we search for this item in the list one by one, and every time the selected item is found in the list, we can keep a counter and we can increment the count every time there is a match. So the logical solution is select an item, item I, keep a counter, then search the entire list for the item I, and every time there is a match, increment the counter. And when I'll be done, or the program will be done searching the entire array, I'll have the number of occurrences in the counter. But I haven't addressed this issue. That is how to not work with one element twice. And that is we can keep another box, and this box will basically store the scene items, which means whenever we start or before I start working with an item, so over here, so at this step, so over here I selected an item I, and before working, so before I start searching and counting, I will search, I'll search inside, let's say this is B, I'll search inside the box B to check if the item I exists. So if B contains the item I, it means the item is seen before I do, and we do not have to work with it again. And if B does not contain the item I, it means we haven't seen it, so we will work with it, do everything, and then put I inside B. So this is to make sure that I don't work with the same item more than once. So let us write the pseudocode. So we're given L1, and what we need to do is we have to create a box. So the L1, so L, it's not L1, it's L. So we're given the list of items, which is L, and before start working, we'll have to create another list. The box I mentioned in the previous slide, B, should be another list because we will be storing multiple items over here. So we need another list. So I have to create a new list and let's name it L2, and which will be initially empty. So this is L2 initially, which is empty. Then we need to have a counter which will be initially 0. Then we'll need a pointer to select an item, and as we will be dealing with every item, the selection should be done using a loop. So we can say for each item I, and for every item we can put the counter over here because the counter is 0 for every unique item, right? So we can do it over here. And as we have discussed in the previous slide, that for every selected item, before I do the search, we need to check if the selected item resides in the box P or not. So over here, the box P is nothing but a list which we named it L2. So I do a check if I inside L2. If it's true, then we do nothing. Do nothing. We simply increment I or move to the next element, or we select the next element. Else, else means that I is not inside L2, which means I is a new item. So according to our plan, what we do is we search the entire list for I. So this searching has to be done from the first element to the last element. So this should also be done in a loop, right? So let's say we need to have another pointer and let's name it J. So for each element J, remember this loop is for this second loop is for finding matches or finding match. So for each element J, remember this J will also start from the first element. So J starts from index 0 as well because we have to search the entire list. So for each element J, we have to check if I and J are equal or not. So if I and J are equal, this means that the I or the element pointed by I and the element pointed by J are equal. This means that there's a match, and in that case, we have to increment the counter, right? And if elements don't match, we don't do anything to the counter. We just simply move J to the next index, okay? So over here, we move J to the next index. No matter if we find a match or not, we will move J to the next index. And when this loop ends, this means that I'm done searching. And at the end of searching, we know that this variable counter has the number of occurrences for each item I. So after this loop ends, we can print the element I is found C time or counter times. And we have to do one more thing. That is, as we are done working with I, we must put I inside L2. Otherwise, we will be working with I again. So please make sure that after you do the printing, you put I inside L2. And after doing all these, you come back to the outer loop or to the first loop and select the next item. Now let us check whether this design or what we have planned is correct or not. So let's use a different color. So let's say the given list is apple, banana, apple, grape, banana, plum, grape, and grape. So this was the given list. And this is L2, initially empty. The counter is 0. So let's keep a column for counter. For each item I, so I initially points to the first element of the list. So counter is 0. So we don't have to write it. We can erase this. Now we have to check if I is inside L2 or not. So L2 is empty, so I is not inside L2. So I go to else. Now again, there's a new loop which starts from the beginning and the pointer is named J. So this is J over here. Now I check if I equals J or not. Yes, both the elements or I and J both are pointing to the same element A. So there's a match. And as a result, I increment counter by 1. So counter increases from 0 to 1. And then we move J to the next element, or I mean to the next index. So this loop continues again. If check if I equals to J or not, I points to A and J points to B. The elements do not match. So I do not go inside if, I simply move J to the next index. Over here, I points to A and J also points to A. Therefore, I increment counter from 1 to 2. And we do the same thing for the rest of the elements and we don't find A again. So when J reaches beyond the length, this loop breaks. And when this loop breaks, we follow this arrow and we move to this line. So I print I is found count number of times. I is basically the element A. So A is found count number of times. Count is 2. And after that, I put I inside L2. So L2 contains A now. And then I move up, which means I will be pointing to the next element now. Again, counter will be refreshed to 0 because now I'll be dealing with new element, therefore count becomes 0. Now before working, I check if the ith element is inside L2 or not. I is B and L2 does not have a B, therefore B is a new element. So I go to else for each element J. Now J again, this is the inner loop, so J again starts from 0, so J starts from here. Like the previous time, J will iterate over every element and J will be pointing to B on a couple of occasions and where there will be a match between I and J and the counter will be incremented twice and at the end I'll be printing B is found 2 times and I put B inside L2. Again, when I points to A, Before starting working with A, I check if A inside L2 or not. Yes, A is inside L2, so I do nothing. So all these will be skipped because I have already seen A and I've already worked with A. I simply move to the next index and work with the next element. So my piece of code or the planning over here seems all right. Now we can move to coding. So the coding part is will be done by you. Thank you.